Hey there, welcome back to the Database MCP series. In this third part, we will focus on strengthening the safety and reliability of our database operations by implementing three important internal methods. These methods are used to validate the insert data, clean the insert data, and validate the queries. This will help ensure that the data we insert is clean, valid, and protected from potentially harmful queries. In part 1, we created and set up the databases that will be used by our database MCP server. This included preparing both SQLite and PostgreSQL environments so that our server can connect to and manage multiple databases. In part 2, we began building the database manager. We implemented the logic for stabilizing connections to different types of databases. We also added functionality to check whether the database connection is active and working correctly, and to retrieve the structure of any table so that later operations can use that information for validation. Make sure to watch those videos before proceeding. Now that the foundational structure is in place, we are ready to add validation and query checking mechanisms. Let's get started. Last time we created a method to get the schema of the table. Let's create another method called valid insert data to check if the data being inserted into the table is valid. We will write define validate insert data, then we will write self table name which should be of type string, then we will add the parameter data which should be of type dictionary, and this dictionary will have a key of type string and the value of type any. Then we will have a schema parameter, and then we will add dictionary as its type, and this method should return the value in the form of list of a string. Let's enter this method. We will write the dog string for this. So validate data before insertion. After doing that, we will add the errors list if in case we have got an error while validating the data. So let's say for column name and column information in schema items, as a schema items contains the column name as the key and all the information as the values. Let's say if the column cannot be null and the default value for this column is not provided. So this column cannot be null and the default value is not provided. So this column should have a value. So what we will do is that we will check three conditions, and these conditions are: we will check if column name not in data. Then through this condition, we will check if if the data we are inserting into the table has this column name, and if this column name is not in the data, Then we will add an error message saying required column, the name of the column is missing. So the column, if not present in the data that we're trying to insert, then this column is missing. So we are trying to insert a data into the table, but this table does not contain the corresponding column. So it will add this error saying required column is missing. Now the data that we are trying to insert into the table contains a column having a null value. Then we will write a message saying that this column cannot be null. So let's do that. We'll type else if data column name. So if the value that this column contains has the null value, then what we will write is that errors append and the message saying column name. Let's add the quotes here. Cannot be null. Now in the third condition, we will check if the column is of type string, and if it contains the empty string, which means the null value for the string, then this is not allowed. So let's do that. We will type else if this instance data column name, and we will check if it is of type string with the help of this function called isInstance, and then we'll type data column name, and then we will remove all the leading and trailing white spaces through strip. If it contains the empty string, then what we will do is that we will append the error message saying column. We will add the name of the column name, cannot be empty, which means that it requires a non-empty value. Now we will check if there are unknown columns in the data that we're trying to insert. So we will do for column name in data keys, then we will write if column name not in schema. So if the column name is present in the data, but it is not in the schema, then we will write an error message saying unknown column, then the name of the column, which is column name or table, and the table name into which we are trying to insert the value. And then we will return errors. After doing this, we will create another method called clean insert data. So let's create this. We will type define clean insert data and then self, and then we will pass the parameter data This should be of type dictionary. Then it will have a string key and value can be of any type. And this will return a dictionary in which the key should be of string type and value can be of any type. And this will clean and prepare the data for instruction. So let's add the doc string for this. Now we will initialize the clean data dictionary. And then we will look through each key value pair in the input data. So let's do that. Here we will write key value in data item. So we are looping through each key value pair in the input data. And if the value is none in input data, then the clean data for the corresponding key value should also be none. Otherwise, check if the value is an instance of string data type. To do that, we will type is instance and then the value and the string. And if it is the case, then we will convert empty strings to none for database insertion, and this respects not null constants properly. So we will type print value and then value strip. So here we are removing the leading and trailing white spaces if they are present. And after that, we will type clean data for the particular key, which is set to clean value if clean value is present. Otherwise, it is set to none. And for all the other data types, we will keep the value as it is. Then we will return the value in data. After doing this, we will create another method called validate query. So let's do that. Underscore validate query, and this will have a self, and then this will have a query. This would be of type string. This will have a parameter called allow schema queries, and it should be of type boolean. By default, it is set as false. And then there is another parameter called allow delete. It should be of type Boolean and it is also set as false. And this method will return the value as Boolean. So with the help of this method, we will prevent some basic SQL injection. So let's write the doc string for this. Basic SQL injection prevention with options for schema queries and delete operations. After adding this doc string, let's first define the dangerous keywords. So let's define them in a list. First drop, and then there is truncate, which is also an SQL operation. We have alter operation, we have create operation, execute. So these are SQL commands or SQL comments that are used in injection attacks. After this, we will check if the delete command is allowed or not. If not allow, delete. So if the delete is not allowed, then we will add the delete into the dangerous keyword list. So let's do that. After doing this, we will write query and then lower, which is set to query dot lower, and then we will call the strip functionality. So this will convert the query to lowercase and remove white spaces if present for easier checking. After doing this, let's define the list of regex patterns for legitimate schema queries. So let's do that. We will write schema patterns. First, let's correct this indent. So we will define a list. Now inside this list, we will add the regular expression patterns for legitimate schema queries. So let's do this. We will create the R string, which means that it is a raw string. And what is R string? I will give you a quick introduction. So generally what happens is that Python interprets backslashes as escape characters. For example, here it's a variable called regular string and it has a value called hello world, which is divided by a new line character. For example, in this case, backslash n, which represents the new line character. So if we print this value, it will print it as hello in the one line and world in the next line. But if we have a path, let's say there is a path variable So we here have a path variable which has a path of a folder as a value. So here in this case, if we print this value, it will print as C in the one line and the remaining part in the next line because here it is interpreting this backslash n as a new line character. So this is one of the issues that we face with Python. And to avoid this, we have this raw string character. So let's say we have this raw string called hello world, and in which we have defined the raw string by using this R word. And then, so we have encapsulated this value inside this R word. So what it does is that it treats the backslashes literally without finding any meaning in the characters of the string. So it does not try to find the meaning in the backslash and other characters. It will treat the string as a string. So if we print this value, we will get the hello world value in a single line. The same way, if we print this path value with all the backslashes, it will print the path as it is. So this is how the raw string works. Now we will add a first pattern. So let's add this. So we will write this exponent symbol, and anything following this exponent symbol means that that string should be at the very first place. So if I write the word cat here, it means that it will find or match all the strings which begins with the word cat. For example, catalyst, catalog, and others. So what we'll write here is pragma. So it will match the first string as pragma, and then we will write forward slash s plus, which means that it can have one or more white spaces character. It means that after the pragma string, there could be a white, there could be one or more. It means that after the pragma string, there could be one or more white space characters like spaces and tabs. And then we will write table and then info. So it means that after the white space character, it should match the word table info. And after that, we will write backslash s, and then we will add the asterisk here, which means that after the table info string, there could be 0, 1, or more than one white space characters. And after that, we will add the backslash. So here we have a backslash parenthesis, and it means that the parenthesis is a literal parenthesis because if we remove the backslash, then parenthesis has a different meaning in the regular expression. So we add the backslash, which treat this parenthesis as a literal parenthesis. Now, after doing this, we will add the next pattern here, and then it will begin with the show, and then it may have the white spaces, and then we will have tables or columns in the pattern. So in this pattern, it first look for the string which begins with the show, and then what is followed by this string is the white space character, and then we have defined tables or columns, which means that either the word tables or the columns are matched. So we have, for example, show followed by a white space, and then it is defined as table, then it will be matched. And if it is defined as show followed by white space, which is again followed by the columns, then it will also be matched. So in both ways, it will be matched. And now we will add the new pattern, and this pattern will begin with the word describe, and then this is followed by one or more white spaces. White space is followed by another pattern matching symbol, which is backslash W plus. So here, this backslash W plus means that it will match one or more word characters. And these characters can be letters, digits, or underscore symbol. Except for underscore symbol, it will not accept any special symbols. So it will only have letters, digits, and underscore symbol. We have to close this as well. Now we will add another pattern. And in this case, it will start with select, and then there is a dot, and then there is a asterisk, and we will write information schema. And here select means the SQL command select, and dot asterisk means any characters or any number of characters. For example, it could be A, and it could be a very large word like philosophy. So there could be any number of characters between the word select and the information schema. Now we will add another pattern, and this time it is select and then dot asterisk, and then we will add SQLite master. So here it is doing the same thing as before. That is, it is matching any number of characters between the select and the SQLite master. So all of these patterns are the part of the SQL commands. Now we will look through each allowed pattern. So let's do that. We will type for pattern in schema patterns. And inside this, we will write a condition like if regular expression match pattern to the query lower. So here we are matching the query with the pattern. And if it is matched, then we will return true. So it means that if the query is matched with the pattern and the schema patterns, then it is a legitimate pattern or legitimate query. And then we will return true to symbolize that it is a true pattern. Now what we have to do is we have to keep this schema query whitelisting code inside of if condition. So let's do that. So we will type if allow schema queries, and if the schema queries is allow, which is a flag, then it will be executed. So what it means is that if schema queries are allowed and the query matches patterns like this, then the function will return true, which means that these queries are valid. Now we will move to the next one, in which we will implement the save data query check, in which if dangerous keywords are found without exceptions, then it will return false. So let's do that. Type if query lower, and if it's the query starts with select, insert, or update. So here, if the queries start with the select, insert, or update, then we will check if there are any dangerous keywords present in the queries, with some exceptions. For example, if create and alter commands are present, then it is okay if they are not related to the table command. And if delete or drop commands are present, then they are okay only if they are part of the select command subquery. For example, if there is a subquery like select all from logs where message like drop, then we will check any dangerous keyword is present in the query with some exceptions. Like For example, if create or alter are present in the query, then they are fine if they are not related to the table. Also, if delete and drop words are present in the query, then they are also okay if they are part of the select subquery. For example, select alls from log where message like drop, then it is fine. But if it is a commands like delete or dropped, and if dangerous keywords are found without exception, then we will return false. So let's do that. Type for keyword in query lower. So we will check if the create and alter words are present in the query, but they are not part of the table command, then they are fine. So let's do that. If keyword in create or alter, so it means that if create or alter words are mentioned in the keyword list, and if table is not present in the query, then it is fine. And if keyword has delete or drop commands and query lower starts with select, then it is also fine. But if we found the dangerous keyword, now if we found the dangerous keyword without the exceptions like the table not in query or the query starts with select, then we will return false, which means that the query is not valid. So the continue keyword will allow the loop to continue as long as the query is valid. And if it finds any invalid query which does not match any of this condition, then it will return false. Now we will check the safety of the delete query. So to do that, we will first type else if query lower, and then we will type starts with delete. So it means if the query starts with delete, and if performing delete is allowed, so within this we will check if the invalid keywords are present in this or not, except for delete, because currently we are dealing with the delete command and there are some exceptions. So first we will not check the delete, we will only check the other dangerous keywords. So let's do that. We will type for keyword in k, for k in dangerous keywords, if this keyword is not delete. So now we will check if any of these dangerous keywords are present in the query. So we will do if keyword in query lower, if the keyword is present in the query, then we will return that this query is not valid. Now, if the delete command is present in the query and it is not accompanied by the where clause, then we will return false, because we do not want all the rows to be deleted at once. We can allow one row to be deleted, but not all at once. So let's do that. If where clause not in the query, then we will return false. Now, if the query does not start with the allowed operations like select, insert, update, or delete, then we will simply return false, because that query is not valid. So let's do that. Now, if the query passes all the safety checks, then we will return true. Let's correct the indent. Now, we will create another method called execute query, which will execute a parameterized query safely. So let's do that. Async Chronos define execute query. Then we will pass self, and then we will give it the query, which should be of type string. Then we will give the parameters, which should be of type tuple, and currently it is set to none. And then we will have fetch all flag, which is of type boolean, and it is set to true. Then we will have limit parameter, which is of type integer, and currently it is set to none. And then we will have allow schema queries. It should be of type boolean, and it is set to false currently. And then we will have allow delete flag. As it is a flag, it should be of type boolean, and currently it is set to false. This method will return the result of type dictionary, in which the key will be of string type and the values can be of any type. Now let's add the doc string for this. We will write execute parameterized query safely. So first we will check if the query is valid or not. And to do that, we will call the validate query method, which we have just created. So let's do that. If not, self validate query, and then pass the allow schema queries, and then we will pass the value of allow delete parameter. So this will call the validate query method, and if the result is true, which means the query is valid, then it will return true. And if it is not a valid query, then we will raise an error. Let's correct this parameter, and then we will now raise an error, which should be a value error, and then we will print the error message saying query contains potentially dangerous operations or missing where clause for delete. And if it is not the case, it means the query is valid, then we will write try And now we will create the cursor which helps us to execute the query. And to do that, we will type cursor self connection. Then we will call cursor. So with the help of this, we will execute the queries. Now we will use the limit clause if it is not present in the query, and if we allow the limit clause to be there in the query. So to do that, we will type if limit, which means that limit is allowed to be added in the query. And we will check if the query is not a schema query, because in a schema query, we do not use limit clause. We only use it in the operations related to data. So we will check if it is not a schema query and it is not a delete query. Then we will set the limit to minimum of what is defined in the limit and what is defined in the constructor. So we will give the value to the limit based on the minimum value between the limit value that we have passed through the parameter or through the maximum result that is in the constructor. Because we are adding the limit clause to the query, because without limit, this could return millions of rows, and this will lead to long query execution time, high memory usage, and sluggish performance, or the code may crash. So we have defined the limit to select the minimum value between the limit and the maximum results that is defined in the constructor. And we can see the value here, it is 1000. Now, after doing this, we will check if the limit clause is already present in the query. If it is present, then we will not add this limit clause to the query. But if it is not present, then we will add this limit clause. So let's do that. We will check if not regular expression search. So we will search for raw string. Then we will use a word boundary like v, and then we will write limit, and then we will also add word boundary here, and then we will write query, and then we will ignore the case, which means the uppercase or lowercase. So we will ignore if it is uppercase or lowercase. We will keep it case sensitive free. So here we are searching for the word limit inside the query. And with the help of this word boundary, what we are doing is that we are only searching for the word limit and not for any word which has limit as substring. For example, let's say there is a word called unlimited. And if it is present in the query, then it will not match. It will only and only match if the word limit is there. So now this is the case. Then what we'll do is that if the limit is not present in the query, then what we will do is that we will add it to the query. Then we will give a space, and then we will write limit, and then we will add the range of limit. And now we will check if the parameters are given or not. It means we are checking if the query is a parameterized query or not. So let's do that. So we will check if parameters are provided, then we will use these parameters in the query and execute it. So let's do that. We will type cursor execute, and then we will write query, and then we will provide the parameters. And I will give you a quick glimpse of what this parameterized query is like. So here we have a query which has select all from users where age is greater than. Then here we have a question mark symbol, which is a placeholder. So it is a placeholder for a value for a parameter that it needs while executing the query. So this placeholder will be replaced by a value that will be provided at the time of the execution of this query. So here we have defined this parameter in a table, and then we will execute this query along with this parameter. So this placeholder will be replaced by 25. So this is how the parameterized query works. And if it is not a parameterized query, then we will just simply execute the query. So now it is correct. Now we will create a response dictionary and we will call it result. And this will be a dictionary. In this, first we will add the key success, and it is set to true, which means that the query is executed successfully. And then we will add the query here that it executes. And then we will add the row count, which refers to the number of affected rows after performing operations like insertion, updation, or deletion. So this result it will return at the end if the query is successfully executed. In the exception block, we will write the success as false, but currently it is set as true. Now we will handle the output of the query. That is what to do after the SQL query is executed via a cursor. So let's do that. First, we will check if a query starts with a particular word like select, pragma, show, or describe. So type if query, then we will remove the white spaces. Then we will convert it to lowercase, and we will check if the query starts with any of the any of the select, pragma, show, or describe. So these queries give the output, and we will define how this output will be like. So for example, if fetch all is allowed, then what we will do is that we will fetch all the rows and add it to the result dictionary. So let's do that. We will first fetch all the results. So with the help of this code, we will get the result of the query. And then we will type data here, which will store the result of the query. So let's do that. So this will be the list of dictionaries. And if the result is empty, then it will return the empty list. So each row will be defined as a dictionary, and all these dictionaries will be encapsulated in a list. Now we will count the number of rows it returns. So let's do that. Result count, and this will be set to length of the result data that has been fetched. So we have defined the number of rows in the output. But what is the difference between this number of rows in the output and this cursor count? So the difference is that here we are actually calculating the number of rows in the output result, and here we are calculating the number of rows that has been affected by the query. For example, if a table contains 10 rows, and if we add 5 more rows into that table, then the row count will be 5 because the 5 rows are affected. But if we calculate the number of rows in the output table, for example, through this, then it will result 15 because these are the total number of rows. And now, if the fetch all is set to false, then we will return only one row. So let's do that. And then we will write here row. Then we will type cursor fetch one to fetch only one result or one row. Then we will type result data. And then we will do the same as before, which is dictionary row. If row is present, else we will set it to none. Now after doing that, we will set the count to 1. So let's do that. Result count, and we will set it to 1 if row is present, else we will set it to 0. Now if the query does not start with any of these keywords, which means that the query is a data modification query. So now we will write a code to handle this. So let's do that. We will write else, and here we will write if self database type is SQLite. So what we will do is we will commit all the changes that has been made from the operations like insert, update, or delete. So let's do that. We will type self connection dot commit, and with this line it will save the updated result. Now what we'll do is that we will store the number of rows that has been affected by this. So let's do that. We'll type result affected rows cursor, and then we will type row count. So this cursor row count will return the number of rows that has been affected by the last query. Let's correct the indent. And after this, what we will do is, so if the query is related to the insertion operation, then we will also store the ID of the last row that has been inserted. This is not the primary key ID of the row. This is the ID of the row in which the last insertion operation has been performed. For example, let's say there are 10 rows in a table, and if we insert a new record with the ID 15, so what this will do is that this will store the value 11 instead of 15 because we are inserting this in the 11th row of the table. So let's do that. So we will type if query strip, we will convert this to lowercase, and we will check if it starts with insert. Then what we will do is that we will store this last insert ID, into the dictionary. So with the help of this cursor last row ID, we will get the ID of the row in which the last record has been inserted. Now as it is done and if everything is all right, then we will return the result. So let's do that. We will type return and then result. And if there is any error in the result, let's say there is an error while executing the query, then we will create an exception block for this. So let's create an exception block. So type except and after this, it should be aligned with the try block. So let's correct the intent again. It is correct now. So here we will write accept block and then we will write exception as E and then we will create a logger error f string. I will write query execution error and then we will print the error that we have got. And after this, if we have got an error, then what we will do is we will return the results, return in which the success should be set to false. The error is set to a string of the error message. And then we will write query, which is set to the query, which has given us this error. So that is it for this method. This concludes part 3 of the database MCP series. We have now added essential validation and safety mechanisms that make our database manager more reliable and secure. These methods will serve as the backbone of our upcoming operations. In the next part, we will implement another validation method and begin building the tools for our MCP server. These tools will allow us to safely insert, query, update, and delete the records across any connected database. If you need help with your projects, have difficulty learning these concepts, or want to deepen your understanding of how things like this work, Codersarts is here to support you. We offer personalized project assistance, one-to-one live sessions, help with building AI-related applications, and full development and deployment services. Visit us at www.codersarts.com or reach out directly at contact@codersarts.com. You will also find our LinkedIn, Instagram, and Facebook handles linked in the description box below. Thanks for watching and don't forget to like and share the video and subscribe to the channel so you never miss out our latest tutorials. Thank you.